Warning, I'm about to tell you something shocking. Come on, that was so funny. So by the time we're done here, we will explore the various PoE standards and understand the benefits of each. So if somebody told me I had to learn a whole bunch of standards, my first question would be, why? I don't want to fill my mind with needless information. Well, there's actually a good reason when it comes to PoE. There's been more than once that I've bought the wrong kind of equipment, matched it up with the wrong kind of power source, and it simply doesn't work. On a good day, on a bad day, you can actually short it out. So what I've done is I've created quite an eclectic slide that tried to jam all of the thoughts about PoE standards and the PoE evolution in one place. So before I dive right in, if you don't have something to write with, you'll want to get something because there's a lot of dots to connect and you'll want to take some notes, okay? So first off, the PoE evolution actually began with Cisco. Now, Cisco usually starts a revolution and the standards body will be off to the races. It just takes them forever to come up with a standard. So around 2001, 2002, Cisco created what they called inline power. And the only reason I mention it here is I know a lot of times people build labs and they're on eBay and things like that. And they're like, wow, look at that. A switch for $5, you know, and it says inline power and they translate that to PoE. It's not PoE. I mean, it is, but it's not. It's not going to be compatible with anything else that's out there. So if you want to know more information about that, just Google. You'll see a whole list of devices that use Cisco inline power, and chances are very good they're extraordinarily old. So in 2003, the de facto 802.3AF was released. And this is the one that stayed the standard for a long time. As a matter of fact, it still is probably the most common standard to this day. And this is in 2020 that people are using, right? So it is 15.4 watts of power per port. Although you don't get that by the time you get to the device. It's going to be something less than that because of the loss that goes through the cable, because of the heat dissipation, all that kind of stuff. Regardless, you'll see it written most of the time as 15.4 watts, which can power most simple devices. Now, this was also where you first saw Mode A and Mode B come out. Mode A and B is what pins are used to transmit the power. The original, and probably the more common, is the same pins that the data uses, 1, 2, 3, and 6. Now, remember, this was coming out in 2003, a time where 100 megabits per second ruled the world. Gigabit Ethernet wasn't really a thing yet, right? So we only used two pairs of the wire to transmit data, and we shared those same pins to transmit the power. And that was okay because they were at opposite ends of the spectrum. They didn't interfere with each other. Mode B, as you probably guessed, used the opposite pairs, 4, 5, 7, and 8, right? So most devices, and I'll say if it's designed to be IEEE compliant, the powers that be that created all these standards, can use either Mode A or Mode B, but I found some of Jeremy's garage sale cheap devices don't. Some of them will be one or the other and sometimes just get a little tricky. Now, speaking of cheap devices, 24 volts is a thing. Now, you can see right here, standard power over Ethernet is 48 volts all the time. Now, and I don't want to get too deep into power. Watts versus voltage. That's one of those things you could Google all day, and it gets pretty deep into electricity. For now, just think about volts as the pressure that pushes the electricity down the wire. Standard PoE uses 48 volts of pressure, but there's a lot of low-end, I'll just call them cheap devices, that use 24 volts. Ubiquity would be one of the cheap equipments that I buy. And they make some good stuff. It's just they cut corners by using 24 volts because it's just cheaper. That is actually something known as passive PoE. You'll hear that all the time. All of these are known as active. Think of active PoE as the safe standard. That's because all these will try and detect if the device is there. If it doesn't see a PoE device, it doesn't supply power. Passive PoE is an on-off switch. You literally go into the switch and turn it on because the switch can't detect if something is a PoE device on the other end. And that's where it becomes very important to be careful what you plug into that port. If you plug in a non-passive PoE device, boom, give it a couple seconds and you've probably shorted it out. And just FYI, passive PoE almost always will be a mode B. So I think I've cleared off, or not cleared off, but talked about all of my different side notes, except for this one, which is a brief side notes. All of these are backwards compatible, except for that one. That's not really a standard. So I can take a 802.3 AF device and plug it into a switch that's supplying this high level of power, and it will be able to power the device. They always make them backwards compatible. So 802.3 AT, released in 2009, is also called PoE Plus. You'll see a lot of that nowadays. That supplies 30 watts of power per port, but again, because of the loss that happens over the cable, you'll never actually receive 30 watts at the device. And that's okay. The devices that are geared to use 802.3 AT, as long as you're using a cable that's 100 meters in length, they'll be able to deal with that. Now, also keep in mind, there are devices out there that can convert from 802.3 AT and even 802.3 BT, which is the one right below it, down to the others. I just purchased a switch, actually, the other day, which is a PoE powered switch. It's pretty trippy. It actually takes PoE as the input, right? You don't have to plug in the switch, and it will take something like 802.3 AT or BT and output 802.3 AF on all the ports. So you could take one single input and it can use 802.3 AF to power multiple devices coming out of that. That's really cool if you've got a faraway device, like for instance, the place I use that was actually out on the patio that I was just showing you a little bit ago by the swimming pool in another video, actually. After I'm like, when did I show that to you? Where I've got multiple devices out there, but only one line coming in, and I need to power all of them. So the other thing worth mentioning is, as an active standard, all of these devices will negotiate the actual power use. So I mentioned this in the other video. The original standard, used a pulse of essentially electricity to determine what level or what class of power it should be at. Essentially class 1, 2, or 3. And that was big jumps of power that was actually required. All of these use a protocol known as Link Layer Discovery Protocol, or LLDP. This is used for all kinds of stuff, but one of them is to negotiate the power that's needed, and it actually does it in 0.1 watt increments. So instead of having these big jumps of classes, like going from 15.4 watts down to 7 watts as one, big jump, you can actually negotiate, and not just one time. It can negotiate as power requirements change. Like maybe the device needs more power. It can send an LLDP message and be like, hey, up the quota, I need some more power right now. So all in all, in 2018, we started seeing 802.3 BT coming out. Now, it's still in 2020, beginning of 2020. We haven't seen that many devices that require this kind of stuff. But when you're up to 60 watts and 100 watts, you're now at the point where you can start powering real computers through a switch port. Now, keep in mind that it sounds like, oh, wow, that's great. Let's just get rid of plugs everywhere, power everything through the switch. The power supply that you need to power those kind of device is just massive. So you're no longer talking a lot of the stackable switches being able to power a whole bunch of devices, because it eats up all the power that power supply can generate in a couple devices. Likewise, you can see the little name I have next to this, 4PPPoE. That's 4-pair PoE. That is, we're now able to use it. It first emerged in Type 3, although Type 3 could use Mode A and Mode B. By the time you get to Type 4, and Type 3 could do it as well, you're only in 4-pair PoE, which is using all 8 individual wires of an Ethernet cable to transmit those higher wattage power. It's a lot of stuff, right? And it's relevant. I wouldn't talk about all the PoE standards if it wasn't necessary to know them, because you'll encounter them literally on a daily basis with the kind of devices that we're running into today. So if you didn't jot all those down, you might run back through that video and watch it one more time. You've now seen the various PoE standards and understand the benefits of each. I hope this has been informative. I just thought of my shocking thing. I'm sorry. It made me chuckle. I hope this has been informative for you, and I'd like to thank you for viewing.